Hello. Hello, everyone. Is the sound okay? Oh. Uh, so please comment using the comment section. And if you had any specific problems from either the textbook, because I have it, or from the WebWorks, let me know, or just comment. One thing before I go over some things from the WebWork is I can see the student progress. I can't show you the names because it's illegal, but you can see that it's all blue, lots of blue. That means you haven't done it. It's due in a couple of days. Make sure you start early because there's some input issues for WebWorks, so make sure you do that. Anyways, so one question that I wanted to cover is how to compute the integral of something like this. Oops. So I don't think we really talked about this in class, but if we have an absolute value, then for WebWorks, you're supposed to interpret this as the area. So if you draw the graph, then it has a 0 at 3, 2 over 3. And then it goes like this. And then if it's less than 2 over 3, then it's negative. So it would go something like that. Okay. And so you're supposed to figure out what the shape. So this is not drawn to scale, but you're supposed to figure out what the area of these triangles are. So for this particular one, at 0, if you plug in 0, you'll get 2. So this is at 2. And at 3, it's going to be, maybe I'll draw it a little bit more accurately. So at 3, the value of this is 9 minus 2, so it's 7. And so the area of a triangle is 1/2 base times height, where this is the base and this is the height. So the area of this triangle is just 2/3. The area of this triangle is going to be 1/2. Base is 3 minus 2/3 times the height, which is 7. So this is going to be 1/2 9 over 3, so 7 over 3 times 7. So I guess 49 over 6. So it's 49 over 6 plus 2/3. Okay. But what if you wanted to use the fundamental theorem of calculus? That is the antiderivative. Well, how do you compute the antiderivative of absolute value? It's not that bad, but it's not just straightforward, increase the power, divide by that number. So here's how you would compute the antiderivative of an absolute value. So the idea is you want to split it up into 2 regions where you know how the function looks like. So we can split the integral up from 0 to 2 over 3. And 2 over 3 to 3. So this is nice because now you are only looking for values between 0 and 2/3. And for those values, the inside expression is always negative. So the absolute value just flips it. So this is actually just 0 to 2/3 of 2 minus 3x dx plus this integral. It's always positive from 2/3, right? And so you don't need the absolute value. Like the absolute value does nothing. And so this is going to be just 3x minus 2 dx 2/3 and 3. And so now you just have regular old integrals that you can use the power rule to integrate. And you'll get the same answer as if you had interpreted using the area. So that's how you would integrate absolute value. And I think later on, we'll talk a little bit more about when the absolute value comes up. So that's question 1 from WebWorks. So any questions, other questions? Oh, I guess let me go through. Let me go over the Riemann sum stuff because I think a lot of people have problems with it, even though it's not that bad. But I don't have really anything planned for this office hours. This is sort of just to test things out. Let me know if the sound level is too loud or too quiet, or if you can't see the screen. Okay, so Riemann sum. The idea is to set up an expression to compute the area. So the area under the curve of f of x from a to b is given as the limit as n goes to infinity of b minus a over n times the sum k from 1 to n of f a plus k times b over n. And that's it. So here's like a question. It might say to set up the Riemann sum, for 0 to 2 pi of sine x dx. And so what do? You just copy this over. That's the limit as n goes to infinity of b minus a is 2 pi over n. So just 2 pi over n. Then the summation k from 1 to n of sine. And then a is 0. And then k times 2 pi over n. And that's it. So any questions with this? Okay, so now let's actually do an example where we can evaluate the limit. So most of the times these limits are going to be too hard to compute. For example, if we want to compute the limit, compute using the limit, yeah, I don't know, this thing, x cubed. then let's first set up our limit. This is the limit as n goes to infinity of b minus a is 1 over n, summation k from 1 to n, and then f of x, that's just the cube function. A is 0, and so it's going to be k over n, and then cubed. So to compute this limit, you can factor out n cubed, so you get limit as n goes to infinity of 1 over n to the 4th of k cubed, the summation k cubed. And so for this, we need an identity. So the sum of cubes up to n is given by this formula. So, well, this is this. It's given by n times n plus 1 all over 2 and then square. So just replace this with this expression. And so we have the limit as n goes to infinity of 1 over n to the 4th n times 1 over 2 . And now this is just a regular old two-way limit. So this is n squared n plus 1 squared over 4 and n to the 4. 4 because 2 squared. And then if you multiply this out, oops, forgot the limit. If you multiply this out, you get n squared times n squared plus 2n plus 1 all over 4 n to the 4th. So if you move that in, you get n to the 4th plus 2n cubed plus n squared all over 4n to the 4th. And then you can do whatever you want. I don't know. So maybe multiply the top and bottom by n to the 4th, or you can use L'Hopital's rule, or well, I guess that's the only two way to do it. And then you get 1 over 4. Okay, and you're going to definitely have to do something like this. You'll be provided this formula or identity, but the relevant one. So you don't need to memorize anything, but you do need to know how to set it up and evaluate the limit. Anyways, just to double check, let's use the fundamental theorem of calculus, but that's easy. Take the antiderivative, 1 over 4, x to the 4, 0 to 1. If you plug in 1, you get 1/4. Okay? No, you don't have to remember the formula. No. And there's not that many ones where you can actually like do the ones where you can actually compute the limit. How about let's do the fundamental theorem of calculus question. So suppose we define a function g of x as like square root of x and I don't know 5 of e to the t square dt. and we want to compute G double prime. Then how can we do this? Well, differentiation and integration are inverse processes. So you don't actually have to take the antiderivative of e to the t squared. It's also impossible to do it using elementary functions. And the fundamental theorem of calculus is if you want to take the derivative with respect to a variable that's in this bounds of integration, so x and x here, then this is just f of x. So you just plug in. And it has to be on the top. So first, let's rewrite this as negative 5 to root x e to the t squared. So now that your x variable is up on the top, this is very nice. So g prime is negative e, and then you take this and you just plug it into the t. So this is square root of x squared. But because it's not just x, you need to use chain rule. So you have to multiply by this guy. So that the derivative of square root of x is 1 over 2 root x by using power rule. So x to the 1/2 prime, 1/2 x to the negative 1/2, which is nice. So now we want to take the second derivative, so we just need to take the derivative one more time. Doing it like this is not a very great idea. We should simplify a little bit. So this is going to be, if we simplify this, we get negative 1/2 e to the x divided by root x. And so to take the derivative of that, we use quotient rule. So quotient rule, let me remind you, is f prime g minus f g prime divided by g squared. And for derivatives, the constants, you can just leave them alone. So g double prime is negative 1/2, and then the derivative of the top is just e to the x times the bottom is root x minus the derivative of root x is 1 over 2 root x, and then e to the x divided by the square of square root, which is just x. And then you don't need to simplify. You can simplify if you want to, but for my exam, and I guess WebWorks, for the most part, you should be able to just plug something like this in, and it'll be the right answer. Okay. Yeah, so WebWorks 1 looks pretty doable. So in the remaining 10 minutes, let me show you kind of a cool way to do integrals. This is just for fun. So suppose you wanted to take the antiderivative, oops, that's wrong, of sine squared from 0 to 2 pi. So how can we do this? One way to do this is to use the trig identity. This is 1 minus cosine of 2x over 2. And so just replace that with that. So this is going to be 1/2, because this is divided by 2. And you can move the constant outside, 0 to 2 pi, of 1 minus cosine 2x dx. And so if we take the antiderivative, we get the antiderivative of 1 is x. The antiderivative of negative cosine is negative sine 2x. But then you have to account for this chain rule. Or I guess you could have done this using u substitution, but we don't really want to waste too much time doing some easy integrals. So we plug in 0 and 2 pi. So we get 2 pi, 1/2, and then 2 pi minus sine of 4 pi is 0. And then plugging in 0, you get 0, and then sine of 0 is 0. So everything is 0 except 2 pi. So you get pi. Okay. But there's an easier way to do this particular one if you use symmetry. So somehow on the interval from 0 to 2 pi, the sine function looks like this, and the cosine function looks like just its shift, like that. But if you're squaring it, then the area sort of in between these things, well, they're all positive or non-negative. And so they're going to be equal. So just by symmetry, you know that the integral from 0 to 2 pi of cosine squared dx is equal to the integral of sine squared. So this is by symmetry over 2 pi. And it's important that it's from 0 to 2 pi. It does work for other parts, but you have to be a little bit careful when you do this trick. So why is this a trick? Is you first write down twice what you want. This is going to be 0 to 2 pi of sine squared plus 0 to 2 pi of sine squared, right? Because multiplying by 2 means you're adding it twice. But then we replace one of them with cosine squared. So this becomes cosine squared. So this is the integral from 0 to 2 pi of sine squared plus cosine squared. But sine squared plus cosine squared is 1. And so this is just the area of 1 from 0 to 2 pi. So it's 2 pi. And so if we divide this by 2, we get that it's pi. You're actually, let me just write it in a separate line. So therefore, 0 to 2 pi of sine squared is pi. Okay. So integrals are kind of fun because if you see sort of a trick to do it, then they're really easy. Okay. So any questions? Okay. Well, I just wanted to test out all the equipment for the midterm review session that I'll probably do the Saturday before the midterm. Is this working? I can't really hear myself, so. All right, well, have a nice break. Or not break, have a nice rest of the Martin Luther King Day. Bye. Oh, thank you.